Welcome back. Last time we fixed the running out of fuel issue with this speedway carb. We also moved the load cell to this location, and that seemed to help a bit. And the RPM sensor to the retarder versus having it mounted to the engine, which also seemed to help a bit. We're at the point now where we can either add more timing, pull out fuel, or increase boost. As I'm pretty sure we're running rich and timing is set relatively low, I think we'll start adding boost. That's kind of a safe starting point for adding boost, don't you think? And adding boost is fun. I'll show you my first step in this boost controlling adventure, and we'll test it. Here's that wastegate, which is used as a dump valve. It's piped into the intake after the blower. As of now, I have unaltered plenum pressure hooked up to the dump valve on this side of the membrane. There's a membrane in here and a spring. Having pressure hooked up on this side acts against the spring and helps open the valve. This means this is set to its lowest possible pressure now. First thing to do is disconnect this line and see what happens. And then we can start adding pressure here to help the spring keep the valve shut and increase pressure. We'll see how much pressure disconnecting this line will give us first. It's immediately obvious that this will not be a safe starting point. It is encouraging how it knocked over my exhaust extraction though. We're immediately halted in our tracks, but in a positive way. I'll have to drive around now, see if I can find a bleed valve boost controller thing. Something to control this. Can't start at this kind of pressure. It's promising though. I managed to find one of these cheap bleed valve boost controllers locally. This will work as a start. We'll switch it out for something more sophisticated later. I also got this big plastic container which will be used for when I'm on fire, but not unconscious from an explosion. And I'm seriously contemplating building a guard for the chain. It's tempting to try this first though. I'm not quite sure what I was thinking here. I was thinking to make room for this to move, but obviously I've given it room to move a lot up to here, not much here. That's more like it. Not the most beautiful thing in the world. It'll serve its purpose though. Here's that cheap boost controller. Works by bleeding off pressure going to the wastegate, fooling the wastegate into thinking there's less pressure than it really is. There's something weird here though. There's an arrow, and the arrow says arrow points toward wastegate actuator. Okay, so this is towards the actuator. There's a ball and a spring here, so it's a one-way check valve. What I don't understand is how this is supposed to work, because this valve will only open if there's higher pressure in the wastegate versus from the engine. I can't really see, this must have been assembled the wrong way or something. I'm just gonna remove that valve, that ball and the spring. Use this as just a normal T. Let's hook this up and start creeping up on pressure. Got it teed into the line now, and the outlet is routed into the exhaust stream. As we're not venting just air, but the air-fuel mix. We'll start with this shut. That should give us about 0.4 bars, and then we'll start opening it and see how the engine behaves under higher pressure. I'm running the dyno in hydraulic pump mode now, so it's not using the PID loop. It's just starting. It's starting at 20%. At 11,000 RPM, and then increases by 5% every second. Simulates a hill that gets steeper. For now, we'll do that PID tuning, but keep it simple. That's at 0.4 bars. I'll start it up again and try increasing pressure. Take it up to say 0.6 or 0.7, and then try doing a run. Something happened. I think maybe the rotary valve is stuck. That sounds plausible. As suspected, the rotary valve was stuck. It's ripped from its hub. You can see it's been grabbing here. It's too thin. It's been able to flex. I've got a plan though. Rolled around yesterday looking for a suitable piece of material, and I found it. This is about 1 millimeter thicker, should be stiff and springy enough. This means more off-axis weight though, and might lead to more vibrations. We'll see. Let's make clearance in the cover and machine this down to this shape. I've cut all the teeth off. They were thicker and would have interfered when I glued the blade down to this plate. I've had mixed result with this glue down, hold down technique. But light passes and there's a large surface area here, so let's hope this works. And yet again the glue down vise failed. The outline is here though. We'll do like so many times before and finish off by hand. Machining the cover should bring no surprises. It's in a vise so it won't slip. I couldn't get the pulleys off. My Allen key was just slipping in the grub screws. It's Loctited pretty hard in there. Just pack the area around the bearing with some Play-Doh. Should be fine. Cover machined, success. The new valve. is ready. I'll reassemble, time it up, and we're ready to go again. We're back in business. Tomorrow morning. I can't wait. I need both hands, so I'll try to fix the throttle a little bit open. It's locking up somehow. Maybe that rotary valve is sealing too well. You probably saw it, I didn't. The belt flew off for the rotary valve. That explains it. I think I've got another one. I've only got this one replacement, so let's hope it holds up. Might need stronger belts though with the added mass of the new rotary valve. I think something got destroyed here. Might be we broke the crank. Seemed like the brake had no effect on it though, and it just revved to the moon. It was my intent to just hold it and apply brake and let it, you know, uphill, but that did not happen. Let's see what happened though. Piston is moving, but there's very little compression. It sticks near top dead center. I have a suspicion the ring broke and it's wedged into the squish band. Let's pull the head and investigate. Yep, I don't think the ring actually broke though, but it seems like it pushed parts of the piston up into the combustion chamber, and you can see the results here. Hard to tell now with so much damage from the piston pieces, but it does look like there's been some detonation here. I've got more pistons, and the liner doesn't look bad at all. And I've got more of those too. The ring pin is located here, and the bridge between the exhaust and the transfer, that's really small. I'm wondering if I need to relocate the ring pin to here, where there's a much larger or wider area for it to ride in. Might be a good idea. I'm calling this a success. We made lots of RPM, we made more boost, we fixed a rotary valve that would fail sooner or later, and just had some minor speed bumps. Next week. See you next week.